Hello and a warm welcome to Agents of Tech, the podcast that explores the possibilities of big data, artificial intelligence and other technologies to improve our lives. And I'm so delighted to be joined again by Autry Godfrey here with me in London, UK. Autry, how are you enjoying this wet, grey London?
I think it's the traditional London I expect, but I am so pleased to be here with you recording this face-to-face today rather than online. We recently wrapped up the American Society of Human Genetics 2023 annual meeting in Washington, D.C. right before I traveled over here. It's their 75th anniversary this year, and more than 8,000 researchers and clinicians convened to celebrate this milestone.
Genetic discoveries over the last 7 decades have transformed our understanding of DNA and developed revolutionary tools and therapies, finding new ways to prevent, diagnose, and treat diseases more effectively.
And at the same time, these discoveries also confirm our common ancestry as human beings and show us that there is more that unites us than divides us. We all have extraordinary genetic similarity, but this allows the investigation of the small but impactful variations between populations that influence disease risk and resilience. While there, we spoke to Brendan Lee, ASHG's president, about delivering on the promise of genetic and genomic medicine.
We've been a field that has really been transformed over the years by technologies that move at a rapid pace. When I look back on my career, we started with things like karyotype, looking at chromosomes under a microscope. We moved on then to being able to sequence specific genes, identify specific genes. And then from there to things like next generation sequencing and now RNA sequencing. These technologies transform the field in terms of our ability to get increasing resolution in human variation. And that then has led us to the research that has taken leaps and bounds almost every decade over the life of our society. So the immediate impact has been on diagnostic rate. We have, as a field, begun to learn about human variation, how changes in our DNA cause disease. These transformative technologies allow us to, with increasing resolution and specificity, identify the ones which cause human disease. The best example is our diagnostic rate of rare diseases. When I was a trainee, we were lucky to identify and be able to attribute a DNA mutation to maybe 1 to 2% of cases. Now, with this technology transformation, we are now able to do this in 35, 40, even 50% of cases. This technology, this ability to make diagnostics is unbelievable. It has changed not just genetics and genomics, it's changed genetics and genomics in genomic medicine of all fields, whether you're a cardiologist, whether you are a pediatrician, whether you're a neonatologist, whether you're a lung doctor. The challenge has been getting these technologies and these diagnostics to all patients, all individuals everywhere. Our vision is that genetics and genomics benefits everyone everywhere. And that is a vision because we have failed as a world, as a health profession in doing that. There are many reasons for that, but the ways that we can overcome it, well, first we have to commit to doing so, and that's really important, identifying the problem and committing to fixing it. I think reducing cost is a very important component. And again, that will be the next transformation. As we take a genome from $1 billion, which is what it costs the first time, to $10, we will increase access. But then there's also the issue of using technology to reach individuals in urban centers, in rural areas who don't have access even to primary care physicians. So I think tele-engagement and telehealth will be very important. But that also then specifies in certain infrastructure that's required. Patients in those areas have to not only have access to these technologies, but they also need to understand how to use these technologies. So on multiple layers, we hope to bend the curve to get to that vision of genetics and genomics benefiting everyone everywhere. I think our community is vibrant and exciting. And as I mentioned in my presidential address yesterday, the science drives what we do and the technology has driven the science, as we've talked about. I think that the excitement that we move the field with is really what keeps us and keeps the field going. I think it's critical also for us to engage. Part of overcoming disparity is to be able to communicate what we do to the public and the public writ large, including the general public, including policymakers, including our fellow scientists. It's important that we don't limit our communication and our engagement just to ourselves. As amazing as this meeting is, and we're sharing great science, I think the real impact is when we get that science out to the community. So I think that every day as a scientist, we need to think of ourselves as citizens also. And in so doing, I think we really will deliver on the impact that our mission makes us do.
Very optimistic about the future there. Next up, I speak to Dr. Rosario Isasi from the University of Miami Miller School of Medicine. Dr. Isasi researches the social, ethical, and policy dimensions of disruptive technologies like precision medicine, genomics, and regenerative medicine. Her work also focuses on societal attitudes towards scientific innovation and the factors shaping technological uptake, public engagement, and support. I met with her while at ASHG to discuss the implications of this for advancing human genetics. Now that we have these advancements in science, the question of how to use it is a hotly contested one. Here to discuss this morning is Rosario Isasi. Thanks so much for your time today.
Thank you for having me.
Let's get started. And can you just share your insights on what are some of the ethical, legal, and social implications of genetic research and how it should be properly used?
So first, let's start by saying, what is this field of study? What is ELSI? We hear all the time, and we sometimes don't know how to define what those implications are. The main focus is in how science and technology impact society. And our particular focus is how genomics and genetic technologies could have and should have a beneficial effects at the population level. So what are those ethical implications are enormous. What are the social implications? It varies depending on the areas we choose to focus on.
So as you know, you mentioned you're an expert in genetics, law, and policy. What do you think are some of the legal and regulatory challenges that geneticists face that still need to be addressed?
So the first one is, and I think it's the focus of the ELSI field of study, in being prospective. So for a foresight approach, identify, evaluate, and address actual potential or current issues that might arise that will have this sort of societal consequences. And from a legal and an ethical point of view, the perennial question is how ethics and policy can evolve at the same pace as scientific developments and at the same pace that societal debate and engagement takes place.
So how do we kind of bridge that divide between research and advancing human genetics and genomics research, and then also law and public policy?
I think one of the best ways to bridge that gap, because in a way it's a gap, is by the field of study itself, the ELSI field of the study itself, and having this type of a scholar is multidisciplinary. They're not only bioethicists or lawyers, we have scientists that work together to try to address these issues and to propose solutions. So we try to see how we can allow science to progress on a safe, effective, and equitable manner. So how to address these issues? Equity.
So, you know, the use of genetics for personalized medicine and personalized healthcare is certainly on the rise. Can you kind of discuss how genetics is contributing to the advancements in healthcare, including disease prevention and treatment?
Yes, but first let's talk about the area that you touched about genetic information and dimension of privacy, because it alludes to the policy, regulatory, and legal challenges you asked before, but also where are we going now? First, genetic information becomes more and more complex. As I always tell my students, remember it has two dimensions, the physical and the informational. Where we gather the information, where we obtain it, how we store it, how we distribute it, how we share, have implications in terms of how we advance and the enormous potential, disruptive potential of precision medicine, but also how we safeguard it. So if we think about genetic information that is collected from a variety of sources and analyzed against a variety of sources, social media, your personal device, electronic health records, how we make now interconnections between genomic data, genomic information, and social concepts such as disability, rare disease. And then you see how the answer of how genomic information can contribute to precision medicine becomes quite complicated and subject to a very lengthy response.
So how can we take, I guess, all of this genetic information that we are gathering at a very rapid pace and use that to maybe address some health disparities or help with health equity?
So how genetic information can contribute to precision medicine, how can contribute to the disparities, is first, the way it's collected, stored, distributed, and used has to reflect the needs, the priorities, the concerns of the broad community. We normally call stakeholders, I mean patients, research participants, policymakers, scientists, etc. It has to be in a way that reflects in an equal manner in the same way the benefits, but also mitigates the harm. So we always say maximize utility, minimize harm. One of them is the misuse of scientific and genetic information, the weaponization information, in a context, in a current societal context where there's a lot of mistrust in science.
How big of a problem would you say that is, the misuse of information?
I think it's becoming a very substantial problem. Problem is not new. It has always been present.
Right.
However, I would say in the last 4 or 5 years, even with the pandemic and a number of issues that put at the forefront health at the individual and the public health level, made us society change a bit how we understand science, how can we communicate science, and how we use scientific information, including genomic information.
So given that concern, as we look to the future, how can we hopefully ensure that the collection of all of this genetic data is being used for the betterment of society?
Yes, and yes, that's a point. Thank you for to address. How is it? I think we need to safeguard it. We have to have safeguards or tools at different levels, at the policy levels, that first ensures equitable participation in genomic research to the whole cycle, and the whole cycle means how science communication. Two is understanding and being responsible in how we portray the results of research. And third is engage the public, engage and query them. Do you, not only whether they understand or not, how they process it, how they make this analogy as we reshape, as I said earlier, our notions, what is health, what is disability, what is normalcy, what is identity, what is race. If we don't understand as a scientific society or the scientific stakeholders these notions and don't understand that we have to invite everyone to the table, we cannot combat mistrust and misinformation.
Do you think that we combat that through more stringent regulation?
Regulation is part of it, but more than regulation, I like to think of a whole policy system that is not only the law or what top-down approach, what the government will say, but also best practice. As a scientific society, ACG is doing a great job in promote responsible communication of science, right? And trying to mitigate, if not prevent, misuse. But again, including all voices, including the public, including individual family communities, to help them also understand their views and how they receive that information, how that information might impact them in a way that creates stigmatization, discrimination, that a response sometimes is then that's mistrusting science or that weaponizing of science for other interests.
This is certainly a fascinating side to genetic research, and we really appreciate your expertise on it this morning. Thank you.
So this is something we also touched on in episode 8 of Agents of Tech. There are these transformative technologies being developed in medicine, but for them to work in an equitable manner, there has to be engagement with the public and all voices need to be heard.
Yes, Stephen, this is the only way that we can all benefit from this research. If we don't have engagement and data that represents all populations, then pieces of the puzzle are simply missing, and unfortunately, we all lose out.
So next time on Agents of Tech, we'll be looking at public health in a digital age, and we have an interview with Dr. Alan Aspuru-Guzik from the University of Toronto about AI accelerating scientific research.
Can't wait for that one. But until then, goodbye.
Goodbye.